Hi everyone, welcome back. This is part one of a two-part video on limiting reactants. So in this part today, we are going to be balancing our chemical equation, determining moles, and determining our limiting reagent. For part two, we will determine grams of product and how much excess is left over. Now don't be afraid, because we're doing limiting reactants. I'm going to take it really slow and explain exactly what I'm doing step by step. Okay, here we go. Let's first read our problem. Solid iron 3 oxide reacts with aluminum metal to form molten iron and solid aluminum oxide. This reaction is called the thermite reaction. And just as a side note, you can find videos on the thermite reaction. It's pretty spectacular. Okay, so first I just need to get my chemical equation before we even mess with balancing. And to do that, I'm going to have to identify my reactants and products, and also obviously convert these names into molecular formulas. So let's identify reactants first. I have two reactants. I have iron 3 oxide, and I'm reacting that with aluminum metal. My products, I'm going to switch to my magenta for my products. My products, let's see, to form molten iron and aluminum oxide are my products. Okay, great. So I'm going to have 4 different compounds here. Let's go back to my blue. Let's go back to the reactants, and let's get molecular formulas for these. Okay, iron 3 oxide. Iron. Oxide just means oxygen. Okay, our iron 3, again, the temptation is to just put a 3 here, but that is not correct. Actually, I'm just going to erase that, because of course the 3 refers to the oxidation state of the iron, not how many irons we have. So oxygen has an oxidation state of +3. Oxygen, we can predict this from the periodic table, has an oxidation state of -2. Therefore, I have Fe2O3 is my iron oxide. Okay, great. That's one reactant. Plus, my second reaction is just aluminum metal. That's actually quite easy. That is just aluminum right there. Now, both of these are solid. They're in the solid state. So I'm just going to put an S here by my iron oxide and an S here by my aluminum metal. Okay. These are going to go to form my products. Let me switch up to my magenta. Here's my magenta. Okay, so what are we forming? We're forming molten iron. Okay, iron, just iron. Here we go. And aluminum oxide. All right, so I've got aluminum. I'm going to have oxygen. Aluminum, I can look at the periodic table and I can see that it has a charge of +3. Again, oxygen is going to have -2. So aluminum oxide is going to look like this. Let's take a look at our states. We're forming molten iron. So iron is actually a liquid. And solid aluminum oxide. Okay, that is a solid. Here is my chemical equation. Now, we haven't balanced it yet. Let's go to my green and let's balance this out. Okay, I'm going to look at my irons first. Let's see, I have 2 on my reactant side. So I'm going to put a 2 here. Oxygen's 3 and 3, that's balanced, great. Aluminum, 1 on my reactant side, 2 on my product side. A 2 here, double check. Looks good. Okay, now I have a balanced chemical equation. Great. Let's switch back to my blue. Now that I have my balanced chemical equation, I'm going to go ahead and calculate some molar masses just so I have them ready to go. So I'm going to calculate molar masses for iron oxide and aluminum oxide, because obviously the iron and the aluminum I can just get from the periodic table. And here they are. Now I'm going to read the question that you will most likely see when you have a limiting reagent problem. And the question reads, if 1.0346 grams of iron 3 oxide react with 0.3582 grams of aluminum, how many grams of each product is produced? Just as a reminder, this is part one of a two-part series. And for this part, we are actually not going to get to determining grams of each product. We're just going to go through and determine our limiting reagent. But I promise, in part 2, we actually will determine grams of each product. So with that said, let's determine our limiting reagent. The first thing we always need to do when we're doing any kind of stoichiometry is we need to convert to moles. So let's take our grams of iron 3 oxide and our grams of aluminum, and let's convert those to moles. So you can see that I have converted my grams of iron oxide here and my grams of aluminum right here. Okay, so now that I have moles of my iron 3 oxide and my aluminum, I am going to test to see which one is the limiting reagent. Now for this video, I'm actually going to test both of these reactants. You do not have to do this. They should both lead you to the same answer, but I'm going to show you that you can test either of your reactants and get to the correct identification of your limiting reactant. So let's start with the iron 3 oxide. What I'm going to do is I'm going to take my moles of iron 3 oxide. I'm going to use my mole ratio to determine how many moles of aluminum I'm going to need if all of my iron oxide is going to react. Okay, so here is my mole ratio. You can see that I'm simply converting my moles of iron oxide into moles of aluminum, and it's just a simple 2-to-1 ratio. So I should need twice as many moles of aluminum. So if all my iron oxide is going to react, I'm going to need at least 0.0129, etc. moles of aluminum. Okay, that's how much I'm going to need. How many moles of aluminum do I actually have? Well, for that, I need to look up here to my previous calculation. This is how many moles I actually have. And you can see that I actually have more moles of aluminum than I need. So if I have extra aluminum, that means aluminum is in excess, and my iron 3 oxide is my limiting reagent. But let's say you didn't test your iron oxide. Let's say you decided to test your aluminum. We should get the same answer. So let's do that calculation. Here are my moles of aluminum. Again, I'm going to use my mole ratio to determine how many moles of iron 3 oxide I need to use up all of this aluminum. So for my balanced chemical equation, here's my mole ratio. Again, this time my moles of aluminum cancel, and I'm converting this to moles of iron oxide. So if I'm going to use all of my aluminum, I need 0.00663 moles of iron 3 oxide. Okay, so that's how many moles I need. How many moles do I actually have? You can see I only have 0.0064 moles of aluminum oxide. I do not have enough. This is going to limit me. So again, my iron oxide is my limiting, which means my aluminum is in excess. Now, if you ever have time on a problem, you can always test both of your reactants, and they should lead you to the same limiting reactant. However, when we're in time constraints, we don't always have that luxury. So just know you can choose one, test it, and you can determine your limiting reagent. Now, something that I like to do to make sure that I am always going to be using the moles of my limiting reagent, and I'm not accidentally using the moles of my excess, or where I'm using my moles of my testing, I'm going to put a box around my moles of limiting reagent, and I'm also going to put a big LR up there for limiting reagent. Now that we have determined our limiting reactant, we can use that to then determine products and determine how much excess is left over. We will do that in part 2 of this video. So I hope to see you there.